Okay, so we're going to do a combinatorial proof of binomial theorem. And the question that we're going to have here is this question right here. So this is the question. We're going to answer this question with two different methods. And the answer will be correct in both of the methods. Therefore, those two things will be equal to each other. Because essentially the number, how many passwords of length n are there when the letters can be chosen from two alphabets, A with X letters and B with Y letters. So how many passwords are there of length n? So let's divide this. Let's say on the one hand side, well, let's figure this out. Let's say I just say I have n slots, right? The password is of length n. And each one of the slots, right, I could choose any of the X letters from alphabet A, and I could choose any of the Y letters from alphabet B. So that means that there's X plus Y possibilities for me choosing this first letter. And then I have X plus Y in choosing the second letter, because the password could be the same. It could be all the same letter. It could be A, whatever. It could be, I could repeat. And I have X plus Y choices for each slot, and we know that we would multiply because I have X plus Y ways of choosing this first letter, X plus Y ways of choosing the next letter, so forth, so forth. This gives me on the left-hand side that there's X plus Y to the n possible passwords. Okay, again, any of the letters could be from either of the two alphabets. So how many choices do I have for each slot? I have X plus Y choices for each slot. There's n slots. Therefore, I have on the left-hand side, I have this. Now, that's one way we count this, right? We count this by just sitting here and, going, okay, well, that's one way. I have this, that it's X plus Y to the n. It's one answer. The other thing that I do now is I'm going to condition on how many letters from B. Okay, so what does it mean to condition on how many letters from B? So every single password has some number of its letters from alphabet B. Right? So there's either no letters from alphabet B, there's either one letter from alphabet B, there's either two letters from alphabet B, and I want to sit here and I want to condition on that. I want to see. So the first question I'm going to ask is, how many passwords with 0 letters from B? So how many passwords with 0 letters from B are there? Well, if there's no letters from B, then all of the letters must be from A. So I have n slots again. So here's n slots. Okay, the password is still of length n, and all of the letters are from A. So this slot here is only X choices now. And there's only X choices for the next one. And there's X choices and keep going. And that means that if there's none of the letters from B, there's X to the n possible passwords with none of the letters from B. Plus, how many passwords are there with one letter from B? So now let's ask this question. Number passwords, one letter from B. That says from B. Okay. How many passwords? Number of passwords with one letter from B. That says number of passwords with one letter from B. Now this one's a little bit more tricky, but let's see if we can figure this one out. So I have, again, n slots. And I know that there's exactly one letter from B. It has to be one. So I have to choose where I place that letter from B. So how many choices do I have to place that? I have n choose 1, right? I have n slots. I want to choose where to put that one letter from B. That's n choose 1. So let's say I put the letter from B right here. I don't know. It's Y, whatever. There's Y possible choices for that letter. So it's n choose 1 times Y, because I have Y, if there's 10 letters in B, then there'll be 10 choices. There'll be 10 possibilities that I could put right here. And I could put that letter from B in any of the n slots. So it's me putting it in any of the n slots. It's n choose 1. And then I have 10 choices or whatever Y choices for that letter from B. What remains is n minus 1 slots with letters from X. So it's X to the n minus 1. And that's with one letter from B, this here. Now, it could be that there's 0 letters from B. It could be that there's 1 letter from B. It could be that there's 2 letters from B, right? So how many possible passwords are there? Passwords, so that's passwords, 2 letters from B. And we run through this same argument. We say, okay, well, let's see, I have n slots again, right? How many ways can I put 2 letters from B? So the first thing is I want to place those 2 letters. So I could put the 2 B's right here, the 2 letters from B right here. I could put the 2 letters from B, over this one and this one. I could put the 2 letters from B, this one and this one, right? So how many ways could I place those 2 letters from B? Well, there's n choose 2 ways to choose my placement from B. That's why that was happening. N choose 2, right? Times, right? I have Y choices for wherever I place it here and Y choices for over here. So it's times Y squared. And then what's left over is just X's. And that's X to the n minus 2. And then this is the number of ways where I could do it for 2. How many passwords with exactly 2 letters from B? Then you count the number of passwords that you have, right? You keep going down. Okay? And the general question that we really want to ask is how many, let's do it over here. So let's go to general. Let's go very general. Let's say, how many passwords with exactly, and I'm writing this very precisely, K letters from B that are of length n, right? So let's see. Let's try and answer this in the general. You go down, and now again, you have n total slots, and you want to choose where to place those K letters. So I have exactly K letters from B. This could be a B slot, right? Oh, this could be a B slot. This could be a B slot. This could be a B slot. I need to, out of the n, I need to choose where I'm going to have my K letters from B. So that's n choose K. So the answer to this is n choose K. And then each of these slots, there's Y choices, right? I have Y letters in B, so it's Y to the K. Times the rest of the slots must be letters from A, and each of that is X. But the rest of the slots, how many slots are left? Well, K of the slots were taken up by letters from B, so there's n minus K slots left for the X, for the letters from A, and there's X possible choices. So this is general. This is the answer to this question. How many passwords with exactly K letters from B? N choose K times Y to the K times X to the N minus K. Now, if we think about this question, and this is the key question, right? If we think about this question, right, this is exactly what I was saying over here. How many passwords with 0 letters from B? How many passwords with 1 letter from B? How many passwords with 2? How many passwords with 3? How many passwords with 4? Every single possible password in the original question must have either none of its letters from B, one of its letters from B, two of its letters from B, three of its letters, so forth, all the way down till all of its letters could be made up of letters from B. So all of its letters would be when there's n letters from B, and that would give us, this is the general. This formula here is the general, and we should see that it's going to sum over k is going to go from 0. There could be 0 letters from B, so that's when k is 0. You just get x to the n. When k is 0, n choose 0 is 1. Y to the 0 is 1. X to the n minus 0 is just x to the n. So this works for when k is 0. For when k is 1, you get this formula, right? When k is 1, you get n choose 1, which is just n, right? But okay, y to the 1, right? K is 1, x to the n minus 1. And we go down, and this is, again, we should see that there's either 0 letters from B, 1 letter from B, 2 letters from B. So k is going to go from 0 to n. The most it could be is n. So the sum over all of these possibilities, k starts off at 0, and it goes to n, and it's n choose k, y to the k, times x to the n minus k, is going to also give us the answer to this question. Okay, all the total possible passwords, right? How many passwords of length n are there when the letters can be chosen from two alphabets, A with X letters and B with Y letters? Well, any password that fits this criteria has to have either none of its letters from B, one of its letters from B, two of its letters from B, so forth, n of its letters from B. And that's represented in this here, where I sit there and I count each one of those things. I say, how many passwords are there where none of the letters are from B? How many passwords are there where exactly one of the letters is from B? How many passwords are there where two of the letters, and I so forth, and I go down and I sum up all these possibilities, and that's the right-hand side. This is one way to count this question. This is the other way. These two things must then therefore be equal because they are both valid ways of counting or answering the same question, counting the number of passwords of length n from two alphabets, A and B.